Tonight, what we're going to be focusing is how to name an acidic compound. An acidic compound is an acid, and they are basically special ionic compounds. And because they are so special, they actually have their own naming techniques or naming rules. Okay, how do you identify it? It's extremely easy. An acid always starts with a hydrogen as its first element. So every acid in this class, when we're naming it, will have hydrogen as its very first element. If it has hydrogens throughout the compound, that does not mean that it is an acid. It literally has to start with H as its first element when you're writing out the formula. So what we're going to first focus on is how to go from a name to a formula for acids. The very important thing to do, though, before any type of naming is to identify what type of naming technique you're going to have to use. So in order to do that, you have to identify whether it's ionic or covalent or an acid. So for the acid, it's extremely easy. What you do is you look for the word acid as its last word. So right here I see for hydrochloric acid, I see acid as its last name, or not last name, its last word. So therefore I know I'm going to have to name it as an acid. Okay, so now what I'm going to do is I'm going to start following these rules right here. Okay, this is a consolidated version of those rules. And I personally, you're going to have this memorized. I personally on the test would have this memorized and write this table that I'm starring right now on the test as soon as you get it. And then whenever you get to an acid, just apply it. This table is extremely helpful when you are naming acids. So first thing though we're going to have to do is we are going to have to check the prefix and the ending. Okay, so hydrochloric acid has a prefix of hydro and an ending of an acid. So I'm going to follow along and I'm going to follow the hydroic acid acid name rules. So first what you're going to do is you're going to drop the hydro and the ic acid and change it to ide. Okay, so I'm going to drop that hydroic acid. I'm going to change the ending to ide. So what I'm going to do is I'm going to be doing chloride. Okay, and if I look at this part up here, I notice that hydroic acid is the acid name and the anion name is ide. The only difference between all acids is the anion name, okay, or the anion, the negative charge. Why? Because all acids start with a hydrogen, so their cation is always H+. So how do you differentiate between all acids? It's only based off of the negative, which is that anion. Okay, and in this case, we're looking for chloride. So what we're going to do is we're going to find that ion on the periodic table or ion sheet. Chloride, because it's that ide ending, is going to be Cl with a -1 charge. Okay, because it's got that IDE ending, you know that it has a charge. Okay, so then it's going to crisscross this ion with H+. The word acid tells us as chemists that the word acid means that it is hydrogen. This hydro prefix that we mentioned before does not mean hydrogen. The word acid means hydrogen. So as soon as you see acid, write down H+ because you know that that's what it means. So then what you have to do is you have to crisscross it, and so you end up with HCl or H1Cl1, but we kind of reduce that to HCl, or don't write it. Okay, so the next one. I see the word acid, so I know I'm going to have to name it as an acid. So now I'm going to check the prefix and the ending. I do not see a prefix in this case, so now I'm just going to look at the ending, which is us acid. So looking at us acid, it's this part of the table, or it's down here. Okay, so what it first says to do is drop the us acid and change it to ite. So I'm going to get rid of us acid and change it to ite. So instead of chlorous acid, it's going to be chlorite. What that means is that I'm actually looking for the chlorite ion, okay? Because once again, the only thing different between all acids is your anion. So we have to differentiate and identify what the anion is because we already know the cation is going to be H+ due to the word acid. So now I'm going to look on, because it's an ite ending, I know it's going to be on my polyatomic ion sheet. So I'm going to look for chlorite. And chlorite is right here. Yours will be a lot bigger, but it is Cl O2 with a -1 charge. So I found the ion on the periodic table or ion sheet. In this case, anything with an us acid will always be on the ion sheet because it always has that ite ending. Okay, and then I'm going to now do my final step, which is crisscross with H+ to get my final formula, H+. So when I crisscross it, I get HClO2, and that is chlorous acid. Last one I'm going to try is nitric acid. Once again, I identified it immediately as an acid because it has that acid as the last word. I'm going to check my prefix and my ending. There is no prefix for nitric acid, but my ending is ic acid. So now I'm going to be looking at this part of the table, and I'm going to be going from ic acid to 8. Okay, but I'm going to really focus down here for my step-by-step directions. So it says drop the ic acid, so I'm going to get rid of that ic acid and change it to 8. So I'm really looking for the anion of nitrate. And nitrate is on my polyatomic ion sheet. All of the ic acids will also be found on your ion sheet because it comes from an 8. So we're going to look for nitrate, which is right down here, and which is NO3 with a -1. Found it on the ion sheet, and now I'm going to crisscross this ion with an H plus to get my final formula. So I have my H plus. I know that it's going to be an H plus because I have the word acid in it, and so when I crisscross it, I get HNO3. All right, now we're going to go the opposite way. So we're going to go from formula to name. So how do we identify it when it's a formula? Well, as I told you on the very first slide, it will start with an H. That's what makes these acids so special, is that they literally start with an H. Okay, so I identified it as an acid because it started with that H. Now I'm going to check the anion's ending. So I'm looking at my anion, which is SO4. SO4 is polyatomic because we have an S and an O. So I'm going to look at my polyatomic ion sheet. SO4 is sulfate. So I'm going to write down sulfate. That's an F. Okay, looking at sulfate with an 8 ending, I'm going to drop that 8 ending and change it to blank ic acid. So I'm going to drop off this 8 ending, and I'm going to change it to ic acid. So it'd be sulfic acid. Now, with the sulf and the sulfates and the sulfites and all this other stuff and the phosphates and phosphates, so with the P's and the S's, just to let you know, we actually say it as we add a ur in between. So instead of actually writing sulfic acid, which I'm okay with, it's just not the proper way, we actually make it sulf-ur. We add that ur, ic, and then acid to make it proper. But if you write the sulfic acid, I'm okay with that on the test because you're following those rules to the T. All right, let's try the next one. HCl. So I'm looking for, first I have to identify that it's an acid, and yes it is because it starts with an H. Then I'm going to check the anion's ending. So the anion in this case is Cl, which is not polyatomic, so I'm not going to be looking on this ion sheet. So it is going to be either ide, ate, or ite. Well, ate and ite are always found on that ion sheet, so it'd be chloride. Okay, so I've got chloride. Now what I'm going to do is I'm going to drop that ide ending, so I'm going to get rid of it, and I'm going to add hydro as its prefix and ic acid as its ending. So I'm going to add hydro as its prefix, so it's hydro, and then I've still got that chlor, and then I'm going to add ic acid as its ending. So this is hydrochloric acid. So we're going to do HClO. Okay, so first I have to identify that it's an acid, and I do because it starts with an H. Now I'm going to check the anion's ending. So because it is ClO, I know that it is going to be polyatomic, and so I'm going to be looking for ClO on this on the polyatomic ion sheet, which is hypochlorite. So I'm going to write down hypochlorite. Now I look at my ending, and it's an ITE ending. So I'm going to match it up, which is this guy right down here. So what it tells me to do is drop that ite ending and change it to us acid. So I'm going to have hypo, chlor, and then now it says to change my ending instead of ite to be us acid. Okay, and I got that also from up here. So if I had that ite ending, I know I would have to change it to us acid. So this would be hypochlorous acid. So some hints to remember when you're making this, like the little chart, is first I ate something icky at the White House. So ate goes to ick, and ite goes to us. So if it was like nitrate with that ATE ending, it is going to go to nitric. And if it's like nitrite, it is going to go to nitrous. Okay, so the ite goes to us and the ate goes to ick. And so you can write those down really fast on your test. So it's ate goes to ick acid, okay? And then ite goes to us acid, okay? And that's all because I ate something icky at the White House. And then the other thing is if you have no oxygen, you're going to add that prefix of hydro. So everything without that oxygen has a hydro, and that really comes from the ides. All ides really don't have an oxygen. So the ides goes to with the prefix of hydro and then ic acid. You do kind of have to memorize this last one a little bit more than the memory of ate something icky at the White House for this top one. All right, hopefully you guys understand everything and have a great evening.